Okay, good morning, guys. Assalamu alaikum. Welcome back to grade 12 mathematics by grade 11 mathematics by inspired teens. In today's lesson, we are going to be continuing with Euclid. I don't know if you guys could hear me. One second. Okay, I don't think you guys could. I don't know. Anyway, okay. Anyway, nevertheless, good morning, guys. Assalamu alaikum. Welcome back to grade 11 mathematics by inspired teens, where in today's lesson, we are going to be continuing with Euclidean geometry, and we're going to be doing some questions together. Okay, so we'll just go through these for now. What I'll do is I'll the detailed going through question with like different approaches and all of that. We'll leave that for the holiday. I'll have a holiday lesson specifically for Euclidean where we'll go through like a bunch of things. But for now, let's just go through like a few questions. We can look at these hints, okay, and some things about proving for a cyclic quad, and just do a question together. Okay, so hints when answering geometry questions. Number one, read the given information and mark onto the diagram if not already done. If this sounds like grade 2 to you, then well, tough luck. You got to do it even so. All right, this is really important. I always preach this. Right, read the given information. That's number one. If you're not reading the given information, that's very upsetting. Right, not reading the given information is just silly, right? Because there is going to be information in the written that's just not going to be in the diagram, or there's going to be crucial information in the written that you won't be able to solve the question without. Okay, and then marking it on the diagram just saves you the time of keep going back to the information, right? Once you have everything concise in the diagram, that makes your life a lot easier, right? And you looking at the diagram, trying to figure out visually what's going on, which angle can you equate to which. So having all the information there really helps. That's number one. Number two, never assume anything. If not given or marked on the diagram, it is not true unless proven. Okay, this is very, very important. This is an issue that many people have. Assuming things. Never assume anything. Ask a student, how did you prove this? Oh, because this is 90 degrees. Why is that 90 degrees? They didn't say it's 90 degrees. It looks like it's 90 degrees. I don't care whether it looks like it's 90 degrees. If it is not given, please, this is actually, sometimes it's difficult because your brain is so wired to certain things that you sometimes just assume it, right? Please always make sure that it is either given, right, or marked in the diagram or something, or that you've proven it, right? If you've proven something's 90 degrees, then you can use it as 90 degrees, especially when it comes to the center. Okay, a lot of the times they'll just assume, they'll just draw a dot that kind of looks in the center, right, but it's not actually in the center. Okay, you need information, some information that actually tells you that this is the center. Okay, or you need to prove it's the center or something. Okay, but if there's just a dot given in the middle, right, you need to, if it's not clear, if it's not explicitly mentioned that this is the center, right, then you cannot use it as the center. And if you find that the question is unsolvable without that being the center, raise your hand and ask your teacher, like, should I assume that this is the center, and let them confirm with you. Okay, because yes, in some questions, unfortunately, they don't like specify whether it's a center or not, and they just expect you to assume. That's not going to happen in your final exam, though, especially like final grade 11. It's not going to happen in your final matric exam as well, right? It is, they have to specify, okay, or not specify, which means that it's not. Okay. Number three, as you proved angles equal or calculate angles, mark them onto the diagram and write down statement, reason there and then. Okay, so this is also another thing. Just 1 second. Okay, this is also another thing. When you prove angles, yes, I agree. Put them in the diagram, okay, and solve for them. Like this, if you prove, okay, this is equal to 50, that's also equal to 50. Neat, get like a clutch pencil or sharpen your pencil really well. Okay, don't write big fat HB, whatever other pencils that you can possibly have. Please don't dirty your diagram, because you cannot sacrifice the neatness of your diagram just for one question. There might be like 6 other questions afterwards that you need to solve. But now, because your question 1, you wrote like 500 things, it might confuse you, right? Use a clutch pencil, have an eraser with you, write neat. If you can, write light, okay, so it's still legible. Just, okay, that's 50, that's 50, so that you can see, okay, I prove this, I prove that, and it's going to help, because, okay, if I prove that, then maybe I can prove this, and so on, right? and then write down the statement and reason there and then. So you can trial and error this with yourself, right? If you oftentimes find that you forget how you prove something, because remember I told you, perhaps you can also solve the entire question on the diagram and then go write everything. Okay, that's just working with the diagram instead of keep on detaching yourself from the diagram. Just solve right, and you don't even know if what you solve for is actually relevant to what you need to prove, right? Sometimes you just be equating other angles everywhere and anywhere because you just know certain theorems that even perhaps you don't need to prove that specific angle, but you just drawing it on your diagram anyway, right? So again, that's a method that really works, like just working with the diagram and then writing everything. But the reason they write down the statement, the reason is oftentimes maybe students forget how they proved something. And you'll see it might not be a thing in easier questions, but in really difficult questions, when again, there's 5,678 lines, then it could be easy to forget, like, oh, wait, how did I actually prove this? Right? So just keep that in mind. So if you do find yourself forgetting, then yes, write down your statement and reason there and then. Number 4, make sure that by the end of the question, you have used all the given information. Okay, we'll go through this as well. This is also an underrated tip, right? Make sure that you've used all the given information. Oftentimes we forget, like just say we're proving for a question and we stuck. Okay, what could help is going to your question, reading what was given. Oh yeah, AB was given as a tangent. Did I try tan-chord theorem? Did I try tan-chord theorem? Did I try this? Did I try that? Okay, so that could really help. Just give me 1 second. Okay, so for the person that said they don't have the Zoom link, it's okay. If YouTube is working for you, just use YouTube for now, and then message me from your new phone, and I'll just add you to the group again or whatever. Okay, so yes, make sure that by the end of the question you have used all the given information. That's also really important. Okay, like I said, it's an underrated tip that if you stuck, right, go to the question and see what was given, right? I'll also 1 second. Okay, so yes, all right. So, okay, cool. Let's look at the next one. If asked to prove something, it is true. Okay, for example, if asked to prove that ABCD is a cyclic quadrilateral, then it is. But if you can't, then you can use it as one in the next part of the question. Okay, so please, nobody's going into the question. They say prove something's a cyclic quad, and then you formulate a whole theorem in a whole 6-line page, a whole 6-line question and answer, 6, 7, 8, 10 lines, proving that it's not a cyclic quad. Okay, don't do that, because if they're telling you prove that ABCD is a cyclic quad, or ABC is a triangle, or prove that AB is a tangent to the circle at this, it is true. That is going to be a tangent. That statement is true. Okay, you just have to prove it. Okay, because it's not given. It's not given like, okay, that's a tangent. They want you to prove it. Okay, so you need to prove it. Okay, and also, if you cannot prove it, right, then you should use it as one. Automatically in the next question, assume that you have proven it and you can use the rules of whatever you've proven. So for example, ABCD is a cyclic quad. You haven't proved it in question 5, but in question 6, you can use it and assume that you have proved it and use ABCD as a cyclic quadrilateral. Okay. Now, one thing that's really important, and sometimes students either get it or they don't. Let's just say we draw in this cyclic quadrilateral guy, right? Okay, now this is a quadrilateral, right? We cannot assume that this is a cyclic quadrilateral because it's not found within a circle. Okay, it's not found within a circle. So for now, of this, just looking at this, this is not a cyclic quadrilateral as of yet. Okay, but then they say they prove that ABCD is a cyclic quadrilateral. So this is for this, right? So I know that ABCD is a cyclic quadrilateral, but I haven't proven it. Okay, so for example, if this is given as X, right now, I cannot say that this is X. And I can't say, okay, D1 is equal to C1, angles in same segment, they both equal to X. Right now, I cannot, because that is me using the properties of a cyclic quad, which I have not proven yet. Once I proved it, if I have proved it, then I can use the rules of it. Then I can use the rules of a cyclic quad. Let's take this now. Okay, so yeah, in the holidays, my plan is to just do a really detailed example with you guys. Like all these rules that I'm discussing, I want to do a practical example in a question. Okay, right now it's not realistic because of time, but hopefully in the holidays, we'll get a chance to do that. Okay, so you have to prove it first, then you can use the rules of the cyclic quadrilateral. So for example, if I need to prove this, and this is X, I can't say this is equal to X, and then say therefore, that this is a cyclic quadrilateral because I've proved that the angles in same segment are equal. No, you have to use other ways to prove that perhaps you're proving that this is equal to X and that is equal to X. You have to use properties of other things. You can't use properties of this A, B, C, D yet because it's not a cyclic quadrilateral. So you cannot use it as properties of the cyclic quadrilateral. I hope that makes sense, right? If that doesn't make sense, tell me, I'll explain it again, right? You cannot use the properties of something to prove it. So for example, properties of a cyclic quadrilateral, you cannot use the properties of a cyclic quadrilateral to prove that it's a cyclic quadrilateral. That makes no sense because while you're proving it, it's not yet, again, not yet a cyclic quadrilateral. Okay, you know that it's going to be a cyclic quadrilateral, but you need to prove it first, and then you can use its properties, right, for the next question. But for that specific question, when proving it, you have to use properties of everything around it. Okay, so let's get to this, right? Proving for a cyclic quadrilateral. So number one is opposite exterior angles of a cyclic quadrilateral. So you can use this rule. If you can prove that the opposite exterior angle of a cyclic quadrilateral is equal to the opposite interior angle, or in this case, opposite angle. Sorry, let's do that. Opposite exterior angle of the quadrilateral, because before you prove that it's a cyclic quadrilateral, it's just a quadrilateral. So if you can prove that the opposite exterior angle of the quadrilateral is equal to the opposite interior angle, boom, you've proved that it's a cyclic quadrilateral. That's one option. Or number two, if you can prove the opposite interior angles of said quadrilateral are supplementary, so if you can prove that they add up to 180 degrees, then you've proved that it's a cyclic quadrilateral. That's the second option. Or number three is if angles are in the same segment. So if you can prove that angles in the same segment are equal, okay, then you have proven that something is a cyclic quadrilateral. Okay, the hint, I remember we went through this last week, the hint for this is that both diagonals have to be given. So in order to use number three, both, not just one, both diagonals have to be given. If both diagonals are not given, you can't even do number three. That narrows it down for you, makes it slightly easier. You can only use number one or two. Okay, so these are the three options for proving that something's a cyclic quadrilateral. Let's look at the last thing. Do not use properties of said cyclic quadrilateral. 1 second, sorry. Okay, yes, this is very, very important, and it's something I mentioned before. Do not use the properties of said cyclic quadrilateral to prove angles. Okay, prove angles using a different method, then conclude that it is a cyclic quadrilateral. Okay, so do not use the properties of the cyclic quadrilateral that you're currently proving to prove any of the angles that you need. Okay, prove those angles using different methods, then conclude that it's a cyclic quadrilateral. Okay, what angles are we talking about? We're talking about these angles, by the way, opposite exterior and interior and all of that. Okay, let's have a look at this. Okay, in the figure, AD and AE are tangents to the circle at DEF. Okay, so remember point 4 told us, make sure that at the end of the question, you have used all given information. So what I like to do is, grab a highlighter, and I used to do this in my exam as well, and highlight important things from the question. Done. so that when I have to come back to the written, if I have to come back to the written, I can just skim through the highlighted parts. I don't have to read everything again. I can just look at the highlighted parts because those are the important things that I need to note. So AD and AE are tangents to the circle at DEF, the circle DEF. The straight line drawn through A parallel to FD, so A parallel to FD, meets ED produced to C. Those like this ED produced to C, that just means that the line continues to C, right? That's in the diagram for sure. And EF produced at B, that's also fine. And tangent AD cuts EB at G, again, that's just touching lines that are touching each other that we can see in the diagram. So the important bits of information I've highlighted. Okay, so that's the first thing, right? You can choose either or, highlight, or you can just put it in the diagram. But I used to do both just because you never know, right? And because specifically of step number 4, like coming back to the question, because we can just quickly read, right? Okay, what was given? Let me just see if I missed out on anything. And you can obviously just, your brain, you're in a rush, right? You're stressed. It's exam conditions. You realize you have 15 minutes left to try and scram and finish through your Euclidean. Okay, so quickly highlight it, so that when you come back to it, you like, those are the only things you need to read. Did I use AD and AE as tangents? And you realize, oh, shucks, I didn't, or whatever, right? Did I use the fact that A is parallel to FD? Okay, so you're just going through to those highlighted things specifically. That's the first thing. Second thing is everything that's given in the written, you put it into the diagram. So AD and AE are tangents. AD and AE are tangents. So what I like to do with tangents is take a red pen, go to where it's a tangent and put a big fat dot. It's a glaring reminder that, okay, this is a tangent. Don't forget to use the tangent. Okay, and the rules around tangent. One second, sorry. Okay, so please just keep that in mind. This is a nice thing to do, and you can try them, right? If they don't work for you, then don't use them. But if they do, more power to you. Okay, then A parallel to FD, A parallel to FD. So that's already given. Okay, but if you want, and you can just go over it in a certain color. Choose a color. Okay, what would also be great if you stick with your colors, like when you're practicing, when you're studying and doing past papers, just say parallel lines you always do in green, or tangents you always do in red, or other things you always do in a certain color. If you can stick through that color scheme the whole way, even in the exam, that could be really helpful because like your brain would get used to it. Okay, so I think that's everything that we have. Prove that ABDE is a cyclic quadrilateral given that E2 is equal to X. Okay. ABDE. Okay. Given that E2 is equal to X. Okay, so this. One second. Okay. So first things first, ABDE, we need to prove that it's a cyclic quadrilateral. What we cannot do is I cannot say, oh, A2 is equal to X, angles in the same segment, my big fat head. I cannot do that because I haven't proved that it's a cyclic quadrilateral. Okay, I cannot use the properties of this specific cyclic quadrilateral just as yet because I haven't proved that it's a cyclic quadrilateral. I have to use other things around it to try and prove angles that are equal. I can either prove that two interior angles add up to 180, an exterior angle is equal to an opposite interior angle, or I can prove that two angles which are in the same segment are equal. So for example, this is also about working backwards, right? You start off with the angle that you need to prove. Okay, it's not exactly in this case, so we won't discuss it, but it's fine. If I can prove, you need to also realize a lot of things in questions. And one of the important things is, if I can prove A2 is equal to X, then I can say it's a cyclic quadrilateral because A2 is equal to E2, and that would be angles in the same segment are equal, right? If I can prove that A2 somehow is equal to X, okay, then I can prove that this is a cyclic quadrilateral for sure. Okay, so that's a good start. That's what we call like working backwards, right? The angle that you have, seeing other angles that are equal to it. Okay, so this has a value of x. I can see, okay, perhaps I can prove that A2 is equal to it. So I need to prove that A2 is x. So if I can prove, this is a good way of solving questions, right? If I can prove that A2 is x, then I know it's a side. Then I can prove the final step of A2 equal to E2. Therefore, angles in same segment are equal. Therefore, it's a cyclic quadrilateral. Okay, this is where you guys come in now. Tell me. I have to prove that ABDE is a cyclic quadrilateral given that E2 is x. How can I work, right? Or you can give me anything that I'm just going to put into this diagram, right? We're going to work through this together. It's sort of like brainstorming. Solving Euclidean questions like brainstorming, right? Looking at the question, seeing what you can fill in, and so on. Okay, also while I wait for you guys, something I would go against, right? Again, these are not like, I'm not telling you 100% follow all these methods, right? Maybe something already works for you, stick to that. If it works for you, fine, keep to it, right? I'm highly against highlighting. Okay, I would rather you use a fine liner and just go over that line. If you want to highlight your cyclic quadrilateral that you need to prove, for example, I'm like against highlighting because I feel like highlighting is really, it's big and obnoxious, and then it works amazing for that specific question. But when it comes to the next question, it's like too much in front of you. Okay, so we have A2 is equal to D2 alternate angles. That's brilliant, right? So again, we're working, this backwards method also works brilliantly, right? Where now we said that, okay, we have E2 as x. Now we need to prove that A2 is x, because then we know it's a cyclic quadrilateral. So now we look at A2 and we look at A2 and we see, okay, what other angles are equal to A2? So working with these parallel lines again, right? Like in Euclidean, right? A lot of the times you're not missing out on something because you don't know the theorem. Like, that's not true. That's probably the furthest thing from the truth. You're not missing out on something because you don't know what alternate angles are, or you don't know what tan chord theorem is. You know exactly what those are, and you are excellent at identifying those in the smaller diagrams. It's just that when it comes to these complications, that's when it gets complicated, right? But simplifying it down, saying, okay, I have tangents, I have parallel lines. Let me make sure to use both of them, right? Remembering constantly, I have parallel lines. Then saying A2 is right by my parallel line. Okay, so since it's right by my parallel line, okay, let me try and use my parallel line. Okay, let me try and use my parallel lines, and that's exactly what this person done. They said that A2 is equal to D2. So for now, maybe you can use just a different color to indicate, okay, that this is equal to this, because we haven't proved that it's equal to x yet, so I don't want to say it's x, right? Even if you want on the side, you can work with a pencil. A2. You don't have to as well. Okay, you don't even have to give the reason. If you want to, you could write alternate angles, right? This is not our main answers now, even if it's rough. If you want to just put alt angles quickly, right? That's maybe another method you want to use. So maybe you do find yourself forgetting, but you also want to kind of work on the diagram. So you can just quickly scribble it in pencil. A2 is equal to D2 alt angles. Okay, B1 is equal to F1, also alt angles. Okay, so that might help us. B1 is equal to F1. It might not help us, but it might. Okay. B1 is equal to F1 alt angles as well. So again, I haven't cluttered my space completely, right? I'm just using different colors to represent different things in a thin writing. Okay. I'm trying not to clutter as much as possible because we don't want to confuse ourselves visually. Okay. So now what can we do? Okay, remember, okay, so I've shown that D2 is equal to A2. That's true, 100% true. Okay, now D2 is actually a bit closer to E2. So if I can prove that E2 is equal to D2, then I say D2 is equal to A2. Therefore, E2 is equal to A2 as well. And then I can prove that something's a cyclic quadrilateral. So now in a situation, okay, we use the parallel lines. Now we look a bit stuck, right? Like, what else can we use? So let's follow step number 4, which again, like I said, it's an underrated step. Make sure that you have used all the information in that's given. So what you do, you go back to your information and you read. Yes, okay. AD and AD and AE are tangents. I haven't even used my tangents yet. Okay, let me switch on my brain. Let me go use the tangents. Where are my tangents? My tangents are here. Let me try and use tan chord theorem, right? Remember, I'll also make notes on all of the rules around tangents, all of the rules around centers, okay? So for example, for now, all of the rules around tangents are tan chord theorem, tangent perpendicular to radius, tangent from common points. I think those are the three, right? So here I cannot, my center is not given, right? So I can't use tangent perpendicular to radius. I can use tan chord theorem, however, okay? Okay, that's also true. AD is equal to AE, tangent from the same point, but I'm most likely not going to use that right now, so I'm not going to write it for now. Okay, what I can use though is tan chord theorem. D2 is equal to X. Excellent, right? D2 is equal to X because if you want to turn your diagram, maybe let's do this. One second. Yeah, I'm doing this because I obviously can't turn, like, if I turn my tablet, it's not going to help you. But you can obviously turn your page in the exam, right? If you want to turn your page, that's also an option. Why am I turning my page? I'm turning my page to just make my tangent flush, like a horizontal line. So that's what my tangent looks like. Okay. So the tangent is here. Remember, tan chord theorem, tan chord, tangent chord. So here's my tangent. Remember, we work with the angle between tangent and chord. So I can work with this chord perhaps. And the angle between this tangent and this chord, okay, this angle here, it's equal to the same angle that's subtended, sorry, it's equal to the angle subtended by the same chord. So this chord FD subtends E. So it creates angle X. It creates angle X, right? So therefore, E2 should be equal to D2. And therefore, that's why D2 is equal to X. Okay, so we've proven that E2 is equal to D2. So again, you can turn your page, right, to work with your tan chord theorem however you want. Or if it makes sense to you this way, then you can. So therefore, D2 is equal to X. Right, the reason for that is tan chord theorem. And therefore, we also know that A2 is equal to X because A2 is equal to D2. Since A2 is equal to X, E2 is equal to X, E2 is equal to A2. Okay, and therefore ABDE is a cyclic quadrilateral. But isn't E2 equal to D2 plus D3? No. Okay, remember, don't stray away from your tan chord theorem. Okay, don't stray away. Let's okay, you see what happens, why I don't like to highlight. Okay, let's get rid of this. Let's maybe just do this. Okay, if I turn it, right, always work with that same ruling that you learned about tangent chord theorem. Angle between tangent and chord is equal to the angle subtended by the chord. So yeah, you work, here's your tangent. Yeah. This thing is skewed. Nevertheless, let's just do this. Here's your tangent. Okay. Here is your chord that comes from the tangent, right? It touches the tangent. Okay. And we work with which angle? We work with the angle between the tangent and the chord. So angle between tangent and chord, that's done. It's equal to the angle subtended by that same chord, which is this chord subtends which angle? This angle here. Okay, so therefore E2 is equal to D2. Okay, I hope that makes sense. I think you taking this whole angle here, which you shouldn't, right? It's always angle between tangent and chord, not angle between tangent and then the other chord. Okay, angle between tangent and this chord that we're working with is FD, and the angle it subtends is E2. Okay, so therefore in this case we have proven, okay, that it's a cyclic quadrilateral. So let's write it out quickly. Firstly, I'm going to say, we can even work backwards. So I can say angle E2 is equal to angle D2, tan chord theorem. Then we can say angle D2 is equal to angle A2. Alternate angles. And remember, you have to mention the lines which are parallel. So AC is parallel to FD. Okay. And I can say, therefore, angle E2 is equal to angle A2. Okay. Forgot one thing. We can just say they're all X. Okay. You can say, therefore, ABCD, or what is it? ABDE. Okay, is a cyclic quad. Angles in same segment are equal. Okay, so yes, remember we have three options for proving that something is a cyclic quadrilateral. Exterior angle of cyclic quad. We could have perhaps used this, but it would have been difficult because we don't have that value. Opposite interior angles of cyclic quad, maybe this and this, or this and this. But because both diagonals were given, okay, so remember you can use, when both diagonals are given, you can use the angles in the same segment thingy. Okay, perfect. Let's move on. It is further given that EF is equal to DF. Prove that ABC is a tangent to the circle passing through points BF and D. EF is equal to DF. Okay, it is further given that EF is equal to DF. Prove that ABC is a tangent to the circle passing through BFD. Okay, so remember, here's BFD. You have to imagine a circle passing through BFD. Something like this. Okay, obviously this is imaginary. You can draw a dotted circle if you'd like. Okay, actually that's not so great, but it's fine because now it doesn't touch at one point. Okay, let's just resize it. That's going to be bothersome. Okay, clearly it's not drawn to scale and it's not going to fit either way, whatever. But something like that, right? You have to imagine a circle drawn through BFD, something like this. Okay, remember the tangent's going to touch at one point. So they want you to prove that this tangent, that ABC is a tangent to the circle that passes through BFD. So this is going to be what we call converse tan chord theorem because we're proving that something's a tangent. So if we work with the upside down version once more, I'm getting rid of all of this. This is X. That's X. Okay, and that's also a cyclic quadrilateral. Now we can use it as a cyclic quadrilateral. Even if we didn't prove the first question, we can still use this as a cyclic quadrilateral, ABDE. Now, let's work here. They want us to prove that this guy is a tangent at this circle here. Okay, let's pretend that that's a circle. So again, you have to work with, okay, let's do a different color actually. Let's do a dark color so that it's visible. Okay, that's a bit better. So we want to prove that it's a tangent here. So we have to follow the same concepts, right? We have to work with tangent and chord, tangent and chord. Okay. So firstly, I have to identify the chord. So let's just say I'm working with this chord, right? I'm not sure exactly which chord we're going to work with. But let's try this chord. Okay. And I'm going to work with the angle between this tangent and the chord. Okay, here. And I would have to prove that this angle is equal to the angle subtended by that same chord. So this chord here, this angle here, subtended by the green chord. So this entire angle here. Okay, angle D1 plus D2. So if I can prove that this purple angle is equal to this green angle, then I've proven that it's a tangent because that's converse tan chord theorem. Okay, so let's look at it now. Basically, I have to prove what? Let's redraw this neatly also. Okay, I have to prove, if I can prove that this whole angle, okay, is equal to this angle. Okay, because you can see that this is going to be the angle between the tangent and the chord, and this is the angle subtended by that chord. Okay, so we have to prove that B1 is equal to D1 plus D2. Any ideas? Okay, this is complicated, right? Again, it's easy to do converse tan chord theorem in a simple example, but when it's upside down and there's 17 lines, that's when it can get confusing. But you see the basic principles still apply, which is still why I'm under the impression, and I still do believe that your basics need to be perfect. Like you really need to know your basics, like really well. Okay, so you're following that same basic concept. I didn't do anything different here. I'm like you. I mean, it's like I can use my fingers, right? You just have to pay careful attention to the lines. Okay, that's my tangent. Highlight, draw in a fine liner if you have to. Right, redraw. There's also nothing wrong with redrawing the picture quickly. Redraw it and then turn your paper upside down. Get your spare paper quickly. Like, let me show you how quickly I can redraw this freehand. Like, okay, what are the important parts? Okay, yeah, here's my circle. I have tangent at E. I have a tangent at D. Let me join them up quickly. Okay, cool. Then I have what's going on here. I have B somewhere here. I have this. Okay, obviously you can even use a ruler, right? You should probably use a ruler to make it easier. I created this triangle, right? Not long, right? Just quickly redraw it because you're doing it for one question, right? You're not doing it for all the questions. So that's this basic same concept of, again, following tangent. Right? If you don't understand your basic, go watch the basic video again. Like, go understand how do we formulate a tan chord theorem? Which two angles are equal? This is how we formulate it. We identify our tangent. We identify the chord that we're working with, and we identify the angle subtended by that chord, and we formulate. So when you have your upside down thing, then you just label it. So you make sure, okay, I can see this is B1. I can see that is D1 plus D2. Okay, cool. So I need to prove that B1 is equal to D1 plus D2. Okay, now it's done. So I dealt with it not upside down. I dealt with it right side up, and now I can solve it upside down, right? So yes, that's the approach you want to take. So now, any ideas? Anyone tell me? Right, again, you stuck, go back to the question, see if you've used everything. Have you used parallel lines for this particular question? No, you haven't. Remember what's also important, and I'm gonna write it down. Work with what was previously proven. Right? They didn't just make us prove that this was a cyclic quadrilateral. Right now we can use it. We've proven the angles of a cyclic quadrilateral, so now we can use it. For example, I can tell you that this angle is now equal to that angle. I don't know if it's going to help, probably not, but that angle is equal to that angle because exterior angle of cyclic quad. This angle is equal to that angle, exterior angle of cyclic quad. This angle plus this angle is equal to 180. This angle plus that angle is equal to 180. Okay, this angle is equal to this angle, this one, yeah, okay, I've said too much maybe. Okay, so we can now use the properties of a cyclic quadrilateral as well. Okay, so that's something we can keep in mind. So we have three things to use: tangents, parallel lines, cyclic quadrilateral. We have to prove that B1 is equal to D1 plus D2. So basically, we already know the value of D2. We need to get the value of D1. We don't just have three things. We actually have four things because they gave us this new piece of information. They're not going to just give us this information for fun. DF. So this is also something you could highlight because it's important and you can come back to it if you need to. Okay, and I put it in the diagram as well. Okay, so that's an amazing starting point, right? We have a triangle, okay, where EF is equal to FD, people. What can we do from here? Exactly, right? So whenever we have this isosceles triangle, right, that's what we want to work with. Okay, D3 is also equal to X. Oh, now we have another angle equal to X. This guy here. Okay, angles opposite equal sides. Let's see if you said it right. Yes, angles opposite equal sides. Perfect. Okay, so D3 is equal to X. That's amazing. Okay, so I've used the properties of I used the equal lines. Have I used, again, go back to the question. Have you used? So again, you stuck and you can't see it. And now you stuck in this diagram and you're trying to use the diagram only to solve questions. You're like, oh, I can't see it. Okay. That's when you can turn back to your highlights. See, okay, I understand I didn't use the stuff in this diagram, but what's actually in this diagram that I didn't use? I didn't use the fact that EF is equal to DF. Okay, I actually did use that. So you ask yourself, did I use the fact that EF is equal to DF? Yes, I just used that now. In this specific question, I may have used it in the previous question, but in this question, did I use tangents? You try using tangents and then you're like, oh, okay, I don't really see anything. There is actually one more thing that you can use with tangents because we didn't use tangent E. Okay. Then you're like, okay, did I use the parallel lines? Okay. Then did I use the new one? You can highlight that as well. ABDE is a cyclic quad. So you see, there's four highlighted reasons. There's no other possibility. Okay, there is, yeah, if it's like only given, if something's only given in a diagram, but the highest chance of you using something to solve this question is going to be from one of these four highlights. The fact that those tangents, parallel lines, cyclic quad, EF is equal to DF. So we've already used this one, right? So you can tick it off if you want even. Doesn't mean you can't use it twice, but you just say, okay, I did use it. All right, there is one, yeah, okay. I use that. Now let me try using the cyclic quadrilateral. What are the properties of a cyclic quadrilateral? All right, a cyclic quadrilateral, exterior angle of a cyclic quadrilateral is equal to opposite interior. Opposite interiors are supplementary and angles in the same segment. Okay, people, tell me. What can we do? Again, we're not trying to prove this question immediately, right? We're not trying to prove that B1 is equal to D1 plus D2 immediately, but we're just trying to use the properties of what we have to just prove different angles around it, right? And then eventually, maybe we'll be able to get B1, maybe we'll be able to get D2, D1. Anyone? Skip this question, we'll get back to it later. See, that's you, you know? Me, I'm solving this question. 5 minutes, I'm done. I'm joking. That's also not a bad tactic if you're completely stuck. Okay, but you see, we're trying to get you out of that getting stuck thing, right? You guys are only stuck because you haven't used one of the properties. There, that's it. Done. You haven't used one of the properties properly. That's why you're stuck. There's no other reason. You're not stuck because you're dumb. That's not true. You're not stuck because you don't know the properties of, you don't know the theorems. You do know the theorems. You are stuck right now because you haven't used one of these properties. Okay, maybe let's use that one. AE is equal to AD. Sorry, EA. EA is equal to AC, I think you meant. Yeah, okay. It's a bit of a weird one because it's like multiple lines on AB and BC, but yeah, we could use that. So from that, we know that that angle is equal to that angle. I don't know if that's entirely useful right now, but that we have that. Okay. So tangents. Okay, I'll give you another hint. Okay, it's to do with cyclic quadrilateral. So you're getting back onto skipping the question, come back to it. Yes, that's a good technique. Sometimes if you're completely stuck, right? But trying to get you guys away from that. Again, like I said, the only reason that none of you have given me an answer yet is literally because you haven't used one of the properties of these four highlighted things. Okay, so that's why you highlight, you go to it. Okay, let's look at the properties of a cyclic quadrilateral. Have you used angles in the same segment? Okay, have you used the fact that there's two angles in the same segment? Can I get the value of another angle that's in the same segment as one of our angles that we know? And the answer is no, but which one? Okay, so that's my hint. That's the next step. Using angles in same segment. Okay, let's do this one. Jeez, is that the time already? A1 is equal to B2 angles in same segment. Okay, yes, that's also correct. A1 is equal to B2. Okay, but I'm looking more to work with. Which one? I'm looking more towards B1. B1 is equal to 2x, brilliant, right? So this one here, T2 plus D1 and B1. Sorry, T2 plus D1, D1 plus D2 and B1 as well. Okay, so I'm looking more at these two because that relates with B1. So I have the fact that B1 is equal to 2x. Okay, why 2x? Because this is x and x. D1 and D2 is x and x. Okay, I'm just going to get rid of this because it's too much. Okay, so now remember, what are we proving for again? Always refer back to your final. Always refer back to what you're proving. Let's put this thing on silent. Okay, so refer back to what you're proving means, okay, I need to prove that B1 is equal to D1 plus D2. So I have the fact that B1 is 2x, and I have the fact that D2 is x. So now you know, oh, I just need to prove that D1 is also x, so that together they add up to 2x. So I need to somehow prove that D1 is x. Okay, another hint, right? D1 is also, what is D1? D1 is an angle in the same segment. D1 is equal to E2. Sorry, D1 is equal to E1. So if I can find E1, then maybe I can find D1. Then I look at E1. E1, it doesn't look like there's much hope for E1. I don't know. Doesn't look like I can prove many things. Maybe I can use the fact that tangent from common point. I don't know. Any ideas? Sorry, I have the wrong angles equal, which is probably why. This, it's AE is equal to AD. You were correct earlier. Okay, now maybe this helps. I do see something that helps us now. Okay, so using that information of tangent from common points, all right, let's try and pursue it. Okay, so when tangents, when we have an isosceles triangle, basically, it indicates to us what? Isosceles triangle indicates to us that angles opposite equal sides are equal. Okay, so because of, I'll ask this, because of AE being equal to AD, which two angles are equal? Because of AD being equal to AD, which two angles are equal? B1 is equal to E2 plus C. Okay, that's also true. That's exterior angle of a triangle. That's normally really difficult to see. That's also true. So angle C is therefore equal to X. Okay, but I see another way. So because I'm talking about this triangle here. Okay, in that triangle, I can see that AE is equal to AD. My reason for that is tangent from common point. So because of that, angle E1 plus E2 is equal to angle D2 plus D3. Why? Because that would be angles opposite equal sides. Okay, I'm talking about this angle. I'm talking about this angle and this angle here. They're equal to each other, angles opposite equal sides, right? And therefore, E1 plus X is equal to X plus X. So it turns out that E1 is also X, right? That makes sense. So E1 is X. Since E1 is X, if I use angles in same segment, this one and that one, I can see that angle D1 is also equal to X. E1, D1 equal to X. Okay, now I've proven that angle B1 is equal to angle D1 plus D2. Therefore, B1, since B1 is equal to D1 plus D2, therefore ABCD is a tangent. This is called converse tan chord theorem. ABCD is a tangent to BFD. Yeah, I'm lazy to write the rules, but we'll do it anyway. Sorry, the answers. Okay, let's start from the beginning. Okay. So first we use the fact that EF is equal to FD. Given. Okay, then, okay, I'm cheating. I have another diagram up here. We said that E2 is equal to D3. This is angles opposite equal sides. Okay, so we said that therefore D3 is equal to X actually. So we don't have to write it. We can just say, let's put it here one time, which is equal to X. Okay, so yeah, E2 is equal to D3, which is equal to X. Then we said, then what did we say next? AE is equal to AD. Oh, then we proved B1 actually. Yeah, we said B1 is equal to D2 plus D3. B1 is equal to D2 plus D3. So I can just say which is equal to 2x. And I can say angles in same segment. Okay, you can highlight or underline this one because you can even like rearrange it if you want to put it in a better order, just so that you can, I don't know, it makes more sense or whatever. Okay, so now you know that this is one of the main angles you're working with. Okay, that's done. Then we said that I think this is the thing we proved. So AE is equal to AD. Tangent from common point. Okay, and from that we concluded that E1 plus E2 is equal to D2 plus D3. Okay, and then that is the same reason. Angles opposite equal sides. So we said that E1, you don't have to write this, but yeah, you can just write it's equal to x, but it's fine. Said therefore E1 is equal to x. Okay, since E1 is equal to x, we said that E1 is equal to D1, which is equal to x. This is also angles in same segment. Okay, then we said therefore angle D1 plus angle D2 is equal to x. And just say proven for this because you've proven D1 is x and you've proven D2 is x in previous questions. Yeah, here we prove that D2 is x. And then here we're proving D1 is x. Okay, so this is the second main one. D1 and D2. And you can say, therefore, sorry, this is 2x because you add them together. Therefore, angle B1 is equal to angle D1 plus D2. Again, we just proven all of that. And you can say, therefore, ABC is a tangent. And then, yeah, is a tangent at, you can just say tangent to circle BFD, converse tan quad. All of those stories. So very long question. Okay. But yeah, and also another thing is there's probably not one approach. There might be another approach to this. It's quite a tricky question. It's the main thing also, it's because it's such a small, compact diagram. I wish that, honestly, I really do wish that they gave you like a Euclidean question that just took up the whole page. So you had like a massive diagram that you could work with so that it's easier to see, but you're going to have to get used to working with smaller diagrams. Okay, look, Euclidean is difficult, right? If you still find yourself struggling, don't worry, you guys, it's just the start of your journey of Euclidean, going through all these complicated terminologies and stuff, like not terminologies, the complicated theorems like the tan codes, and I think I'm pretty sure that's the first time you guys are learning it. My number one thing is practice. If you do not practice, you're just not going to come right with this. I can teach you as much. I can teach you till I'm blue in the face. Okay, but if you're not going to practice on your own, this Euclidean is not going to come intuitively to you. It's not going to come naturally. It's not going to come easy. It's not going to become faster at it. You have to practice Euclidean. If you want to get an A, especially, you have to do a lot of practice until it clicks. Okay, Euclidean, sometimes it feels like, it's not always the case, but it feels like you either see it or you don't see it, right? You have to force yourself to see it by practicing a lot. Okay, that's the main thing. Okay, look, yeah, we're going to end it on Euclidean there. Okay, but in the holidays, we're definitely going to revisit this, and I'm going to come up with a bunch of notes, right? Just a different bunch of approaches, things that you need to look out for, tips and tricks and helps, and as much as I can to help you. Okay. We're going to revisit Euclidean in the holiday sometimes, and I'm going to try and do a question on each concept that I tell you about, each reminder and helpful tip. I want to show you what I mean and how I want to execute it in the specific question. Okay, so just keep that in mind. But yeah, tough question. Okay. But again, I don't know if you noticed, like, for example, when we were stuck and no one was giving me any answers, we didn't use this. We didn't use the properties of a cyclic quadrilateral. And again, that's the occurrence. The important things highlighted, right? Understand that there's no, I don't know, what's not here. There's no center, okay? So in this question, it's not possible that I'm going to use angles at center is equal to 2 times that angle circumference. No, that's not possible. There's no center and there's nothing drawn to the center, anything like that. Okay, so all the rules and answers that I'm going to get are from these 4 highlighted points. A tangent's drawn parallel to FD, ABD is a cyclic quad, EF is equal to DF. Like all the things that I'm going to prove are from these 4, nothing else. Okay, so just revisiting, and again, it's going to come better with practice. I'm going to sound like a broken record, but it's going to be better with practice. Like it's going to come easier every time you practice. Okay, so yeah, all of these things. So just going through these properties over, like in your head, like going through them. Okay, did I use tan chord? Okay, did I use tangent perpendicular to radius? Okay, that's not possible. Did I use tangent from common point? Oh, I didn't. Okay, make sure those lines are equal and so on. Right, so that's the approach you want to take. Okay, also working backwards is really important, right? Understanding like, okay, this is the angle I need to prove. What other angle can I prove that's equal to this angle? Okay, working backwards, that's also a method. And a lot of things like redrawing, using fine liners, using highlighters, putting everything into the angle, blah, 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 blah. Okay, a lot of things. But yeah, hopefully by the holidays, we can get a good, clean, concise notes on this, so that you have all the notes you need, you have all the advice that you need. Now, then it's just up to you to practice. Okay. Yeah, but for now, these are like really, really good hints. Okay. Never assume as you prove. Okay. Again, I'd like to, because like it's one thing, I'm sure many teachers say, don't assume anything, but then people still assume. Okay. Maybe I feel like doing it with an example, showing you, listen, my guy, stop assuming in this situation. Then you're like, oh, in that situation, oh yeah, I do assume, type of thing. Okay, so hopefully in the holidays we can do that. We can go through each of these things in a question. But yeah, I feel like I've talked enough. I'll leave it open for the next few minutes. If you guys do have any questions, please feel free to ask. Other than that ends Euclidean for us. And I'll send a poll in the group to see what you guys want to do for next week. And we'll do whatever has the highest votes. But yeah, okay, good luck for the exams. I hope that the exams that you're currently writing have been going well. Again, it's going to stay up for the next few minutes. But for those of you who need to leave, you are free to leave. Thank you guys so much for joining, and I will see you guys next year. Probably you're welcome. By the way, if you filled in the questionnaire that I sent out, I know exactly which are your responses. But okay, cool. Doesn't seem like anyone has any questions. Thank you guys so much for joining. I wish you guys a good week at school.